Okay, folks, LLMs are all the rage at the moment. They're on the front pages of newspapers. They're on the news. They're the topic of dinner conversations. This has never happened before. For some of us who've been doing language technology for many, many years, nobody has been interested in language technology until now. And there's all sorts of overhype and truths and untruths, and we're going to learn everything over the next hour or so. So before Pedro comes up, I've already waved this book at you early this morning, and Gail reminded me that to let you know that there are plenty of other copies of this outside. If you wish to take more home to give to the movers and shakers in your part of Europe, please do. There are more bags for you to put the books into. We can help carry them to your preferred means of conveyance, as long as it's not too far away, because they're quite heavy. So there's plenty of copies of this book, but there are also copies of this book around, the sister book, which predates this one by about a year. And you may have noticed in the where we had lunch and where the poster session was, that there are copies of this book as well. So please, if you are interested in extra copies of either book or both books, please help yourself and take them away. I should hold them up the right way. I can't take credit for both of the books, although we were a partner in a small partner on the ELG project. Okay, so without further ado, there was an intervention earlier on from Konrad, who was saying that you want to say something? No. Okay. From Konrad saying that these large language models might enable the field to be leveled a little bit, and more precisely, one of those things are called multilingual large language models, which Pedro is going to talk about now. So we'll welcome Pedro up onto the stage.
Thank you. So my name is Pedro Ortiz. I'm a researcher at DFKI in Berlin, and I'm going to talk a little bit about developing multilingual LLMs and also about the Open GPTX project. So let's start with a little, motivation. So one thing that we are always saying is that these language models are getting bigger and bigger. And when they get bigger, so most of the people are talking about the number of parameters that you can see here on the graph, but not a lot of people are actually talking about the data needs of these language models, because as the number of parameters and as the architecture itself gets bigger, well, the data needs and the number of words or tokens that you need to train those models get even bigger. As you can see, it's various orders of magnitude bigger in some cases. So, what about the data that goes into these models, or the things that they are actually using to tackle all these downstream tasks that we all know about? Well, right now these language models, or the latest large language models, have data needs in the trillion tokens. Let's say space. This is between multiple terabytes and sometimes even petabytes of data. And to give you an idea of how much data that is, we put a little graphic of the printed English Wikipedia. This is around 4 billion, 4.8 billion, if I'm not mistaken, words. And we actually need trillions of words or trillions of tokens. So yeah, you can try to scale it in your mind and try to imagine how much data that is. So one thing that I think it's important is that these data sets that we are using to train these models are getting so big and so large that we don't have any way of effectively auditing what's inside them. So we cannot manually audit them, and we don't really know, in some cases, what's exactly inside them. What we do know, or what we expect from a computational linguistics point of view, is that these data sets should be diverse and should be balanced, of course, because we are creating a general purpose language model, and we want it to be able to model as many use cases, as many topics, as many objectives as easy as possible. So the question is it actually balanced? Well, in practice, no. What you can see is that here we have the data distribution for the Llama model developed by Meta or Facebook. You can see that most of the data using these large language models right now is coming from the web. What we can say about web data is that it's not at all balanced. It's diverse, yes, but it contains a lot of unwanted content that you might want to filter, of course. Otherwise, you're going to have particularly, well, unwanted results when you actually try to use your language model. We can also see that there's a lot of programming language or code, source code, that is actually going into these language models, but not even in the realm of, or the ballpark of the web data. And we also have public domain books, encyclopedias, things like Wikipedia, and in some cases, even scientific articles. But yeah, the thing that I want to convey here is that it is not balanced at all. And then the question is, this is an English model. What happens if you actually want to do a multilingual model? Well, the question is, it's balancing that data even possible. Here you would have, here you see the data distribution, of the Blue model, which was trained by the Big Science workshop, and you can see the disparities between the languages. And well, you can imagine, or you can try to guess how balanced is the data, let's say, by topic or domain inside each of these languages. So, okay, so now let us talk a little bit about OpenGPTX. So OpenGPTX is a project that is trying to create open European large language models. This is because, well, these language models are becoming more and more important in general. But they are mostly coming from the USA and China. They are normally, of course, because they are coming from these countries, are not available in most of the European languages. But they are becoming increasingly important. And well, we actually want Europe to ensure that technology, ensure also the data independence from Europe, and be competitive with these, well, companies or actors in both USA and China. So OpenGPTX is a project that trains open European large language models. We want to follow the European standards of data protection that some of these models coming from USA and China do not. We want to, well, foster innovation across Europe with these models. And, well, we are funded by the German Federal Ministry of Economics and Climate Protection. So the project is going between January 2002 and December 2024. It makes part of the Gaia-X ecosystem. So ideally, we on the project are going to use the federated catalogs of Gaia-X, and probably at some point also become part of that federated catalog. We have a big infrastructure that is provided by Jules, the Jules HPC system in Jülich, but we also have computational resources coming from other organizations. Here you can see the list of partners in the consortium, and the consortium is well, led by Fraunhofer. So let us talk a little bit about what we are doing as DFKI in this project. So, well, one of the parts or one of the key points of being open is that we want to make these models accessible, but in making them accessible, we also want to work a little bit of the compute requirements. So my colleagues, Malte Ostender and Georg Rehm, worked a little bit on these questions, asking like, okay, is it possible to reuse a model, a large language model that is already available, and maybe can we add languages to it? Well, the answer is yes, we can. We can do transfer learning, but the traditional cross-lingual transfer learning is a little bit expensive sometimes. You have to take the large language models and effectively continue the pre-training. So they developed this progressive approach in which you take a smaller language model that is trained, let's say, for German, and then, you use the smaller language model that, let's say, is trained for German to add that language to an already existing large language model. So this approach actually works quite well. It outperforms the traditional cross-lingual transfer in which you continue the pre-training. And it really reduces the training effort compared to training a model from scratch. So here we calculated, for instance, for Bloom, it reduces the pre-training by 80%, the compute by 80%. So with this technique, we effectively added German to Bloom, which was a large language model that didn't contain German in the first place. Okay. I don't know if the demo is going to work. Oops. Well, no, the links are not working. So, okay, I invite you to go to both opengptx.dfki.de and opengptx.dfki.de/chat. So these are actually two of the models that we developed at DFKI. One is the base German model that is derived from Bloom with the approach I just described. And the second one is this base model fine-tuned for dialogue and instruction in German. So you can play with those. Please know that we are still working on this. This is still a research model, so it's going to generate content that you might not like or that might not be factual. So please be careful with it. But okay, I said that we wanted at OpenGPTX to develop European language models. So we have already a German language model, but we want to actually get these technologies to other European languages. So how are we doing this? Well, we are let's say, researching how to do it first to this Oscar project. This is a project of mine that I developed during my PhD. The idea here is just developing pipelines that take web crawl data, filter them, and try to find the documents in that data that are higher quality. So again, in research, what we want to try to see is if we can have a model that has multilingual data coming 80% from the internet in order to mimic a little bit what that llama model was doing. And we are using the corpus provided by Oscar. But the first thing that you can see is that we have a very particular steep hill to climb in order of language distribution because it's not balanced at all. We would like to see something more like this. And what this means is that we had to cut a lot of data in languages like English, which is quite easy. But then we have to actually find more data in some of the low-resource languages. The way we are doing this is actually through a collaboration with European Language European Language Equality. With this collaboration with ELE, OpenGPTX through DFKI reach to our colleagues and try to ask for data in their languages. So we know that highly curated data is crucial for these kinds of models, especially for languages other than English, because what I can tell you is that in web data, the lower resource the language, the more degraded is the quality in certain cases. So we really want to have access to curated datasets that are properly documented and where the content and the legal status of the document is known. For the moment, we have the target size of 100 billion tokens, or around 10% of the data. And we want the distribution to be as balanced as possible. So this is a community effort. Right now, we are relying on native speakers that we think are the best resource for these types of data sets. And this is something that we recently started. There have been already 42 contributions, but well, as you can see here, these 42 unique contributors have already provided us with pointers to quite a lot of data sets. As you can see, the distribution when you reach to native speakers is quite different from what you expect from something like web data. Here at the top, we have normally lower resource languages like Catalan, Danish, and Romanian. Of course, you have English in the fourth place, but you can see that we can find data for a lot of these languages that tend to be more under-resourced. The other thing that it's important is that all the contributions actually include pre-training data sets that, of course, we want to use for our model, but also evaluation data sets, because, again, we have to bridge the gap in pre-training, but we also have to bridge the gap in evaluation, because we can say that a model works for, let's say, Maltese, but if we don't have any data to test it on, we don't really know. So that's one important thing to say. The other thing is, there you can see the statistics for the pre-training dataset entries. And then you can also see the numbers of entering by license. And something that is quite remarkable is that most of the entries in this catalog for the moment are open license, which we are very happy with. On the last one there at the bottom right for you, there you can see the number of entries that do not contain any personal identifiable information, which we think is also very important because we don't want a large language model to repeat this. We don't want large language models to repeat personal data, of course. So please, if you are a speaker of one of these languages, it would be very helpful to us if you can contribute, if you can give us any pointers to existing data. So the form is up there and is going to be up there still. So please go there, fill it in, and probably contribute to the OpenGPTX and European language equality collaboration. So thank you.
Okay, so moving swiftly along, I mean, both Jussi and Pedro have talked about resource efficiency. So Barry is up next and is going to talk about the performance and high performance of language technology. So we'll welcome Barry up on stage, please.
Hello, thank you. So I'm Barry Haddow from Edinburgh, and I'm going to talk through a Horizon Europe project that we have called HPLT, or High Performance Language Technologies. Okay, so this project started in 2022. We wrote the proposal in 2021. So where does it come from? Thinking about language, we want to create a language data space, and we want this language data space to be big, and we want it to be good. So if we take the language data space and combine it with model building and tool building, then it sort of incentivizes us to make sure that it's actually big and good, because then we get good models coming out the other end. So if we have all these things together, the data gathering, the reproducible tools and the model building, then we can get a better data store. So just a little more detail about what we're doing. The concept of the project is to take petabytes of data, and I'll come on to where that data comes from, and turn that into language data sets. What kind of language data? We want to create bitexts, so parallel texts, and we want to create monolingual texts. And the world has changed a bit since the project was conceived, so probably the emphasis on parallel text is not as strong as it was 2-3 years ago. But for us, it's still an important part of the project. And we want to create, another aspect of the project is that we're involving high-performance computing organizations to try to make Firstly, to try to make NLP a bit more friendly to high-performance computing, and secondly, to try to make high-performance computing a bit more friendly to NLP. Try to bring things together a bit. So as I said, the project started last year, last October, and it'll run for 3 years. And this summer is major panic because we have a first data release which is due at the end of September, so 3 months' time. This is from our website to try and summarize the project in numbers. So where do we get the data from? We have a contract with the Internet Archive to bring over 7 petabytes of their data. Common Crawl can give us 5 petabytes as soon as they've fixed their download speed. We have some prediction that we'll get maybe 2.5 trillion words monolingual text. That's based on a lot of extrapolation from things we've done in the past. We're aiming to cover about 80 languages. I'll come on to them in a second. And yeah, building hundreds of translation models, ingesting other corpus from various sources. For instance, our project builds on the work of Opus, which has been going on for many years, based in Helsinki, and building on their corpus ingestion. So this is something from the proposal, and this is very much a projection, but based on what we've seen in the past, we sort of sorted the languages into, let's say, 5 categories, based on how much data we would hope to get. And obviously, as echoing just about every other presentation, English is just way up there, 1.5 trillion words. Other languages, obviously a lot smaller, but again, the European languages, German, Spanish, French, and Russian, obviously, are still pretty big. The language coverage, basically we sat down and we said, we're going to cover all the official languages of Europe, we're going to cover a good quantity of the unofficial ones, and all other important world languages. We're pretty open to covering whatever languages we can. We will attempt to spread into more low-resource languages if at all possible. Sort of project timeline. So this September, we've got to have a first data release. The first models should be coming out next spring at the latest. So we would produce monolingual corpora in at least 80 languages by texts for many pairs of languages, at least those 80 paired with English, and substantially more. The language models, that's sort of in flux. I guess when we set this up, we looked at it and we said, well, what we need is language-specific language models, and the 3 main architectures would be decoder-only, encoder-only, and encoder-decoder. In the last 6 months, decoder-only language models have sort of nosed well out in front, but we'll see how that goes. And we want to have high-performance translation models for all language pairs. And this is sort of building on the OpusMT work. OpusMT, if you know about it, they have translation models for every language, but they're not always the best translation models for that particular language. So we like to have as close to the best language translation model for that language as we can make it. So the tooling, it kind of builds on the existing tools in Opus, for instance, and the Bitexter collection. So Bitexter has been in development for 10 plus years, mainly based around Alicante. And it's a tool for harvesting parallel text from websites. So you take your website, pull down the text, and it aligns them. The basic idea is to translate non-English text into English and then use some similarity-based alignment. Opus Cleaner is a kind of new thing that's coming out of the Bitext tools and being created for this project. The concept is that you'll be able to look at your kind of catalog of corpora and figure out what you want and figure out how to clean them. Opus Trainer is going to be for training MT, and it's what we're using to do our MT training. Megatron obviously is not developed by us, but the key thing we've had to do is port it to AMD hardware, because the bulk of the training is done in Lumi up in Finland, which is a large AMD GPU cluster. And we're extending the Opus API, which is going to be how you actually can programmatically interact with our parallel core pattern models. So just some graphs to show the progress at the moment. We focused on getting the Internet Archive because we figured that was going to be the most difficult. So we've got something like a third of the data that we expect to get, so that's 2.5 petabytes. We have our old crawls. This project was built on top of the Paracrawl series of projects that you probably heard of. And then we have some data from Common Crawl. We're kind of in discussions with the Internet Archive about, so far we've taken the approach of, okay, give us some data sets, we'll download them and see what's in them. We've opened discussions to try and figure out what's actually in the data sets. Obviously, if you've got a petabyte of data, you don't really know what's in it, but they kind of know how they crawled it. So if we try and figure out, how can we get at the sort of, at least the lower resource languages from around Europe, if we can focus a bit more on them. Some sort of early statistics on the language data. So this is just dumped straight from a Jupyter notebook where somebody in the project had done some analysis on the data extraction. So this is basically running language identification on document level, and language identification is a can of worms in itself. So looking at this data gives you some sort of ideas as where things are going and where they might be going wrong. In terms of European languages, the languages that you expect are at the top, so English, Russian, German, French. Asian languages are probably more prevalent than we kind of wrote in the proposal. Whether that's a real thing or whether that's because we're counting bytes here, I'm not entirely sure. When I look at this, it seems that there's a lot more Greek than I would expect, but I don't know, maybe that's just all maths, I don't know. So, it's early days. This is what we're looking at the moment. So the path to the first release, we've got a list of 95 languages that we're working on. Some projection of about 90 terabytes. That's before deduping. The bytex, we've got a spreadsheet of 46 languages paired with English that we've got to work through. Essentially just means running the bytextra pipeline. We have the Marian models that we can use to run the bytextra pipeline, and that's all set up in Lumi. I should emphasize that this is a sort of, the project isn't just about creating a data release and then we run away, creating a model release and run away. It's set up to do 3 years of continuous integration. So we need to have tooling that can just keep on going. So we have our data. For instance, I mentioned language identification. Language identification is probably going to be better in a year's time. So we need to be able to rerun things. We're going to look into the data. Once you start looking into these, you're going to see bugs. So it has to be a reusable pipeline which can take the data and spit out good models at the other end. So yeah, just contact information. Our website, the partners involved, obviously it's us at the University of Edinburgh. It's coordinated by Charles University, who are also here. We have 3 other university partners, all based in Scandinavia, and then we have 2 supercomputer partners, CESNet and Sigma 2, and then Promsit, who come from the bytextra heritage. Yeah, thank you.
Cool. So thanks to Barry, we're a bit more on time than we were, although we started late. So I'm hoping that we can go a little bit past our scheduled stop time. But our final speaker in this session is Michael, who's going to talk about the OpenWebSearch project. So hand straight over to Michael.
Thank you very much. I tried to keep it also short so that we hit the coffee break in time. So welcome from my side. My name is Granitzer. I am coordinator of another European project called the OpenWebSearch.eu project. It is not primarily in the language space, but in the information retrieval space. But I think due to the last half a year, there is a lot of overlap now there. So I want to briefly introduce the project. It's also in an early stage, so I started similar like Barry in October 22, and we also have an upcoming deadline, so I feel the pressure, the same pressure as you felt now on me, and we also have to deliver something. So what is the idea behind the project? Well, in short, we want to create a base for an open European infrastructure for internet search. And the motivation is based on the observation that web search, internet search, has become a critical infrastructure for us and our society. But it's in the hand of a few global players. So even if you see a lot of small search engines, they are basically backed by the same index. The same web index is driving most search engines. And there are two indices in the Western world, that is Google and Bing. And so the idea is to open up that space, to open up that ecosystem. On the one hand for web search, but also on the second hand for allowing us to tap the web as a resource. And if you look, the project started in October last year, but if you look now, large language models and how they are foiled, what is the ingredients? It's data. And it's primarily web data. And it's astonishing to see that the trend that triggered off is a lot of common crawls data, where there is one person crawling the web or one person responsible for crawling the web, majority. And this kind of foil is there. And I often have the impression that for us researchers, it's quite hard to tap into that resource, that it's a petabyte scale. Although we just want to do something on a smaller scale, terabytes or even gigabytes. So I briefly will run down the goals we have and also introduce the partners. We have 14 partners that are, on the left side you see the academic partners, mostly rooted in information retrieval. And on the top right, with LLZ, CERN, CSC, who is also running or majorly leading the LUMI consortium, and IT4I are supercomputing partners, which we want to bring together. Then we have a set of NGOs who are interested in opening up the web search, like OpenSearch and LNet and Zoomer, and there is a business partner for the exploitation part. So what do we want to basically achieve? Our first goal, and I think the most important goal, is to build an open web index. That means a web index is basically that data structure that is the core of every web search engine. It allows us to access web pages fast and rank them to some sort of criteria. And it is, of course, also that one thing that big search engine providers will never open up because it's their core business. And so you don't give away your core business as data. But our idea is to build that openly, similar to like building open language models, and then give that index away as open data. So if you're interested to create a search engine for Basque, then you can do it so by specifying I want to have all Basque data. Give me also the index for that, so not only the raw data, but already the information retrieval engine, and you can have a Basque search engine with the data we have, let's say, one day. And the idea is that this takes away the burden of a lot of small innovators and smaller companies who have not access to infrastructure and brains that run that infrastructure for taking on the web, and bringing the web down to a manageable level. Of course, all other open principles should also apply to that index, so it should be transparent and clear how that index has been created. The contribution should be clear, and we also would like to see a more collaborative management of that index. For example, if there is one organization particularly fond of a subject, like say particle physics and CERN, these are two pairs that match very well, then they should also overtake some kind of quality assurance in that part of the index. And I think that is also a subject now with LLMs that becomes more and more important, that we are having other means for assuring quality, otherwise the web content will for sure degrade over time. So the second goal, as I said, is to create an open infrastructure that basically looks on the coarse grained level like that. We have on the left side, we have a platform that does the heavy lifting that is currently in development, that starts with crawling the web, that then does some cleaning and pre-processing, where we already have some libraries out there that perform quite well to extract the main text and remove the boilerplate code, but also then to have metadata extraction going on with existing entity linker and whatsoever. And then also on the final part here, to create an index, an inverted index file that allows you to be downloaded and then loaded into Lucene or some other information retrieval library, maybe also already including some neural embeddings for improving the ranking, and then you can run on a smaller scale your own search engine. So that's the first part we are focusing on. We hope that this open, and that will be the core outcome, I would say, for the project. We hope that this kind of index then opens up the way for new search applications. One search case we are doing in the project is science search. Another one will be geolocation search, so connecting web content in the geocoordinates that are mentioned in the text to content from the German Aerospace Center. But of course, there are also data products. The proposal, we wrote knowledge graphs and subsymbolic knowledge representation. Nowadays, everybody is thinking, of course, about LLMs. And we still hope that we could provide some content that is there. And we already discussed in the break that there are interesting approaches for crawling still that bring in more of this long tail, I would say, of languages, not only the majority. The third idea or the third concept is that we will have, or that we aim for a distributed infrastructure as an enabler. That means we want to bring together the large European consortium like they are in Euro HPC, but add the additional task of that they should do data-centric AI. And Jussi explained that in the beginning. I think that's the difference if you do HPC computation for climate simulations, or if you do and train large language models. You need compute for both, but on the one hand, you also need the data. And there we also discussed with people from CSC, with Per Oester, that they have the compute, but they also need the data, as also Pedro laid out in the previous section. And so that is the basic idea. For all these components, we also aim, because the project will not deliver a full-fledged thing in 3 years, that would be a little bit too much, but we hope to lay the foundation for building up an ecosystem around that. So on the tech side before, I think there are many contributions from the data side, from content curation, also technological contributions on main text extraction and parsing. I think there are a lot of contributions that from the open community that need to go into there to really grow beyond a single project. Also for the applications, I think it's not only about language models, also in the future there will be specialized vertical search engine, maybe new search paradigms with argument search that could be built on top of that. Of course, language models is an issue, but also benchmarking. And as I said, this network of partners. This is a sketch of the architecture that is planned, and I don't want to go into every detail. I think we use the current web standard. I think just the important part is that this blue bar there should be a federated data infrastructure at the petabyte level across data centers. And we currently have 3 data centers who already started to collaborate there, because from my perspective as a researcher and also what I see as in this project, it's often that really the data storage is the problem. If you go somewhere and say you need 10 petabytes of storage, you can right away turn around and go back again because no computing center has that. But I think we can somehow achieve that by connecting those partners and putting our requirements in this whole community of Euro HPC, because they're doing a wonderful job on making compute available in Europe for researchers, and we need to go there. So I think this is one heart. The other heart that we have, and that is also something that will come, hopefully, is a kind of workflow federation across the data centers to get off this nitty-gritty, small detailed technical stuff to make data-centric workflow work across data centers. And Yeah, one benefit of a central data infrastructure would be also quality assurance, quality control for data that is in there. We always thought about evaluating search engine and search engine rankings, but I think such an infrastructure might be also needed for large language models or language models in general. Due to the time, I skip our crawler part. Maybe the most important thing for crawling, of course, we want to crawl. We aim also to contribute with crawls similar to common crawls, but we also want to go beyond. But we also see that there should be a cooperative crawling. That means there are a lot of crawling efforts going on, and we heard also crawling, and we think we could somehow coordinate them with a central service that knows which URLs have been crawled, with putting out jobs for crawling. And this is what you see here on the top, which is called the frontier in the technical term, but it's just a system that manages which URLs should be fetched next, maybe also topic-wise, language-wise, and we would hope that then we could also reduce the effort for crawling on every individual site, the associated necessary resources for that, and also combine the crawls in one storage infrastructure. From the timeline, the pipeline implementation and deployment, the first one should be in September 23. So as I said, I share the same burden as Barry. And we also want to continue the crawling from September onwards. The small setup is currently really small, 1 terabyte per day. So nothing really big. But we then hope to scale up to 10, 20 terabytes per day on web crawls that are there. That also means that these web crawls will be cleaned, partitioned, and then also indexed, so that not only the data is there, but that you also can look into at least parts of the data via a classical keyword-based search. Don't expect anything like Google search, that is far behind, but a simple search and then the ability to download the index and fine-tune your search is that what we think we will be able to deliver. And there are a lot of future challenges also ahead, like legal compliance in crawling, intellectual property rights, copyrights, GDPR. We started in a project asking a lot of lawyers and legal experts, are we allowed to crawl? Because all our data centers have the fear, of course, to have illegal content there and so on. And the astonishing answer is nobody knows exactly. Yeah? So you have 3 lawyers and 5 answers. So. And I think this is also an important step that we have some kind of central authority, not only about knowing we're allowed to do it, but also to take over the legal risks associated then and have a liability of risks somewhere hidden behind and not on the shoulders of the individual researchers or people who want to do cool stuff. Yeah. There is also additional advantages like digital sovereignty, etc. I don't want to go into detail due to time. I just want to stress what also the Lion Group said, that we need, I think, an open infrastructure to make also a counterpart to the bigger companies to really have something like I cannot say open AI community currently, you have to say open source AI community. So something analog to the open source community that brought so much value into our society. We need something also on the AI and language side, I think, or text side. Okay, that's it. It took a little bit longer even when I hurried, but yeah. Web and web search is critical. We want to build an open infrastructure to do something against that, and thereby also contribute to language diversity, and large language model, hopefully. And so thanks for your attention. And I'm open for questions. No, good.
Okay, so thanks to Michel for that. He was on time, or slightly under time, so he's a bit too self-critical there. So lots of work going on large language modeling in Europe, and 4 experts to fire questions at. So I welcome back onto the stage Barry, Pedro, and Jussi. And I think it worked well this morning, where people identified who they were and where they were from. And again, it would be good to hear from people who haven't had a chance to speak just yet. But this is your chance before the coffee break to ask any question you like about large language models to 4 prominent participants in Europe. So mics on both sides, so we're looking for some hands. It's a bit dark. There's one right at the back. Yeah, Philippe. Or Jane, maybe? Try Philippe first.
Why me first? No, I first. Yeah, because I'm closer. Okay, I'm taking that. Just one question. Well, it's a request. Could we stop talking about token, word, sentence, petabyte, and the like, and find something coherent between all the different groups? It would definitely facilitate the life of everybody, including me, when I need to do the analysis of the things. Thank you. It's a request, not a question.
Yeah, I think somebody mentioned that, and they said how difficult it was to try and predict, how many words there are in a petabyte of data, for example, and we saw even included in the data sets, there's data of different types. So I don't know, it's a well-meant question, but difficult to achieve.
It's a reasonable request, but I don't know if there's a good way to count tokens across languages.
There's also another aspect to it. The focus on white space delimited words in some languages is quite useful, in others less useful. And of course, as those of us who consider themselves linguists would like to include other linguistic items in the same mix. It's not just tokens. So let's just make this even more complicated, and then some of us will be happier.
I know there was a question at the back, Jane.
Maybe just very quickly, if I can add something to that, I think we might have a way of actually communicating this. This is something that happened to me when I did the first release of this Oscar dataset. People were asking me how many words are in your dataset, and I said, I don't know. Maybe I can count somehow for English, but what's a word in Chinese or Japanese? I don't know the answer. So what I normally do is that I just release the sizes of the dataset in megabytes, gigabytes, terabytes, and that can give you an idea of how much content there is. But again, uncompressed.
Okay, question at the back, and then there's a question in the middle here for you to come next.
Thank you. Good evening again. I have 2 questions. One is, what are the problems we are facing with the HPC communities, with high-performance computers? And the second question, you know all that the European Commission has built a translation for the languages. Do you have any, it's for all the community, this question, do you have any relations with this work? Do you have any cooperation? You exchange ideas? Because it's a very good work, as I think. Thank you very much.
Maybe I can answer one part of the HPC community. I don't think the HPC community has a problem, or there is a problem. They have just built tools for different purposes, like simulating climate change or medicine or those kind of things. And if we want to build on HPC computing, we also need to bring in the data aspect and more data-centric workflows. And that is, again, a challenge, but I think they are open to it. We just have to work with them.
I think a specific technical challenge that we have is we create our tools, and our tools rely on having lots of small jobs, and HPC centers can't do that. They have maximum queue lengths, so we end up having to have sort of a sort of hierarchical setup where one of our jobs is then parallelized into many other small jobs. I mean, it's not, technically you can overcome these problems, but it just creates a certain amount of friction when you're trying to set up your pipelines. On the second aspect, we've had collaborations with the people in the, you're talking about the DGT e-translation, as they're called now. We have had collaborations and discussions with them in the past. They've used our data, for example, they have used Paracrawl. I'm not sure if they're using Marion at the moment, I couldn't really say. They definitely used Moses in the past, and I think possibly using Marion, so they have used our tools. So there's, it's not like a really tight collaboration, but I don't think there's any DGT people here. But we have had ongoing discussions with them and exchanges of tools and data.
Questions coming? Pass this one in the middle here.
Tamás Varadi, Hungarian Research Center for Linguistics. A quick question to Michel. When you start rolling out the crawl data, will you have applied language identification beforehand so that we can identify the individual language chunks relevant for?
Yeah, yes. This is the first step. That is boilerplate cleaning of HTML and language identification. That will be there.
Answer was just what we like. I've been given permission to eat into the coffee break by 5 minutes, so I know we've just passed the microphone back that way, but if we could pass it back the other way again. There's a question here, still in the middle.
Sorry for this back and forth. Yeah, so I'd like to hear that all these projects are going on, but still, I mean, your project started now, right? In October. This means you are like half a year, a little bit more into the projects, and like in 2-3 years from now, I would guess that well, also these big world competitors, right, will also advance, right? My question is, are you bringing some kind of innovation which could challenge the big guys, right? So conceptual, scientific, so something which wouldn't be just, you know, providing a European enabler, right? So for digital sovereignty and all these other things, right? So something which would challenge actually the big guys, maybe to be slightly orthogonal to whatever is happening elsewhere, right? So you understand my point. So we cannot be just followers, right? So so the point would be also to lead here and there. I know it's a little bit provocative.
No, it's not provocative. I think if it's directly to me, I think if I would already know which technical innovation could come out and spark everything and removes OpenAI or whatsoever, then I would stop talking here and work on it. But I think it's more. Also, when I talked to Thomas Mikolov, who went to Google for working on word embeddings, we talked and asked why he went there. It said also he had the opportunity to work on big data sets. He had an infrastructure to do that. And so I think it's also not only on the tech level or the innovation level, it is about also keeping our brains here in Europe, giving them opportunities, yeah? Giving our researchers opportunities in order to be able to compete with because we talked, I think, in the break about web cleaning, boilerplate removal, and so on. These are things that are hard to do, things that we need to do in order to get something qualitatively out. But it's also the thing we waste our time with compared to other competitors that already have that sorted out. Yeah, and I think that is the important part. If it's a new innovation or a new algorithm, I don't care. I see it more really as an enabler for our community or for us. I hope that.
Yeah, I'd like to emphasize that there's no lack of innovative research. Yeah. There's no lack of innovative entrepreneurship either. But the path from the one to the other, that pipeline is a bit leaky and rusty. So there needs to be an infrastructure there in place to make it easy for someone who has a brilliant idea, who hooks up with interesting startup scenes in many of the European tech capitals, and then there's something missing that stops that from growing into a large company. And that something is partly a political thing, but it's largely actually a tech thing. It has to do with computing infrastructure, the availability of it, and let's say encouragement on the part of the various institutions involved. Because there's the notion that it's actually, yeah, just do it, it's possible. That needs to be better implanted in the research labs and in the entrepreneurial scene. There's a piece of the puzzle missing there that is there in some parts of the world, not all.
I think if I may add something, like a very good way in which we can innovate right now in Europe, and it's actually, I would say, easier for us than for big companies to do so is in language. Because, well, the problem right now is that if you look at most of the products that these companies are deploying, they are mostly in English. Yes, there's a little bit of multilinguality there, but I can bet you that if you look at the languages on details of the distribution graphs that we show here, like most of these big tech products are not going to work well for those languages. And what we have in Europe right now that they don't have is actually the interest to work on those languages and the knowledge of where are the resources for these languages, how can we develop technologies for these languages, and how can we make these things available. The second thing is that, well, we tend to be a little bit more constrained in terms of computational resources, as compared to these companies. And we honestly are very good in Europe at developing solutions that tend to produce results that are similar and sometimes competitive, especially in these languages, with the big tech companies, but that consume way less resources than the technologies that they are developing. So I think at least in those two spaces, we can already today compete with these big tech companies.
Okay, I think our time is up. Thank you to all our participants. I heard collaboration coming from all four participants. I think that's something that you can see embedded in what they want to do, and that's not going to happen with the big players. They're in competition with each other, whereas each of you said that there were ways in which you can avoid redundancy in this sort of complicated space. But I think that was a very refreshing session. I hope you enjoyed it, and let's give our thanks to all four participants again. Thank you very much.